Hello everyone, in this podcast we are going to attempt to use the crisscross method for determining the formulas for ionic compounds using the oxidation numbers, also known as oxidation states. And we are going to identify how to name ionic compounds. Okay, let's get... Alright. Now, as you can see, this is a periodic table of elements. Taking a close look at group 1 and 2, these are metals. These metals tend to form ions. Okay, let me get my pen working. There we go. These tend to form ions. +1 ion, +2 ion, and moving across to the other side. These are our nonmetals, and they too like to form ions, negative ions. -4, -3, -2, -2. As you go down period 16, you will notice they're all -2 as the preferred ion. Group 17, -1 as the preferred ion. So what does this mean when they try to bond together? Well, let's take a look at some examples and see how it works. Let's make this smaller. Good, that's out of the way now. Let's take an example of lithium. Lithium is Li and it has a +1 charge. How do I know? Let's bring back that periodic table so that I can confirm it for you. Move that over. There it is, +1. Alright, so let's get rid of that. And let's make it form with, let's just say fluorine. And fluorine, let's change the color on the pen just to have a little bit of fun. Fluorine, negative. Okay. The positive implies a +1, the negative implies a -1. So what we do is we do what's called the crisscross method to identify the number of each of the elements necessary. Drop down a 1, drop down a 1, and now your formula becomes LIF, because we do not need to write the ones. If we're writing the letters, the symbols for the elements, it's implied. Alright, let's do another one. Now let's take an example of sodium. Sodium also is a +1, but this time let's use oxygen. That's a -2. Alright, so what would this then look like if we use our crisscross method? Whoop. A 2, whoop. A 1, it gets rewritten as Na2O. So far so good. Let's do some more. Let's do now beryllium. Be2+, and let's see what happens when it combines with sulfur, which is a 2-. Do the crisscross, a 2, a 2. Now this is a 2-to-2 ratio. A 2-to-2 ratio could also be reduced to a 1-to-1 ratio. What does that make the formula? BeS. Okay. Now let's get a tiny bit more complicated. Alright, let's do calcium. A 2+, and let's choose one that has a -3. Okay, here we go. Do the crisscross. Whoop. Whoop. And we have, and that is our formula, a 3-to-2 ratio. Now to naming them. Okay, to name them, we write the metallic ion first. So, write the metallic ion first. Do not modify its name. Next, write the nonmetal with its name altered. How do you alter it? Cut off the end and add the suffix IDE. In reality, because it's at the end, it would be lowercase IDE. Let's try some. Okay, so here we see 5 examples of ionic compounds. Let's put a line here so that we can see with clarity what we are doing. Change the color of the pen. Let's choose green this time. Okay, the first element, lithium, oxygen. What would we name it? This is lithium oxide. The next one, sodium, iodine, but we modify it to be iodide. Sodium iodide. Next, we have potassium nitrogen. That now becomes potassium nitride. Next, calcium and oxygen becomes calcium oxide. And lastly, magnesium and phosphorus becomes, yes, you guessed it, magnesium phosphide. Okay, well there you have it. We summarized how to use the crisscross method to put together the formula for ionic compounds, and we took a look at how to name these compounds. Now later on in the quarter we might have to get into a tiny bit more complex manner in which we name things, which has to do with whether or not the first oxidation state is chosen or ones that are below. And where that comes into play is here. Here, when you notice that iron has the opportunity to become a +2 or a +3. Oftentimes on the reagents they do like to combine iron with another substance so that it actually is forced to use the +3 version. And in doing so, you do have to identify which oxidation number is being used, and that's called the stock system. Anyone wants to look it up, do some type of YouTube search for the stock system of naming compounds, and you'll find it there. Otherwise, we'll touch on it a little bit later on. Thank you very much for your time, and have a wonderful night.